Talk by Gamma, keeping you connected and protected.
Welcome to DAS Talk, the essential podcast on distributed antenna systems and in-building communication. Hosted by Peter, VP of Gamma, and Philip Nicholas. This Gamma Electronics series focuses on emergency response and safety. Join us as we navigate the challenges of building effective communication systems for North America's first responders. We delve into the advancements in emergency responder radio systems and the transformative impact on new technologies. Tune in for insightful discussions aimed at increasing knowledge and awareness in the DAS field. Whether you're a professional or an enthusiast, DAS Talk is your gateway to understanding the nexus of technology, safety, and communication.
What's up, guys? This is Peter with DAS University and Gamma today. Welcome to our program on DAS Talk. So glad we've got our guests together. We've got Luke Mitchell with MorCom, and we've got Gil Martinez with Gamma. And today we've got an amazing program planned. We're going to talk about some frequencies. We're going to talk about how RF components can kind of help you out, can give you a hard time if you do it the wrong way. We're going to talk about some tricks of the trade. We're also going to talk about how amazing Luke is at his job and what he does. And I can't wait to dive into it. So Luke, go ahead and first start off and tell us a little bit about yourself and what you're doing, your history about RF and all that kind of good stuff.
Well, yeah, thank you very much, Peter and Gil and DAS University for having me on. I really appreciate it. So my name is Luke Mitchell. The British accent hides my American citizenship a little bit, but I originally was born in the South UK and I was a trained chef until someone picked me up hitchhiking and said, have you tried communications? You want to apply for this job? And that started a journey that spent a few years in industry doing telecoms, 15 years in the British military doing radio frequency systems, starting in long-range HF, VHF up to 15 kilometers, group chats, and then everything else from point to point in Iraq war to counter-ID terrorism in Afghan, to nuclear, biological and chemical warfare systems in the UK, which brought me into public safety in a big way. I'm working on the public safety scene. I lived in a number of different countries. I helped design and build the public safety system in Bermuda, which got taken on over COVID. And then I eventually moved into MorCom almost exactly a year ago as their director of technical programs. So my job is all things RF, but at a higher level, and then understanding what technology is there, understanding how we can best use it to the benefit of our customers and the industry, in fact.
So tell us a little bit about Bermuda. What did you do there? I'm curious.
Yeah, so I was the general manager of a company that had a Tetra network on the island, and we would sell either private networks for organizations like the dockyards or the military at one time, or allow them onto our network as users. And we would have a few thousand subscribers coming onto our network every day, and we would run the network. However, when the government of Bermuda decided that its 20-year-old Motorola P25 network was not fit for purpose, they'd had some quite horrendous natural disasters, and the system had fallen over every time. They asked for a competitive bid, and so I put together with a team a Tetra bid. So we had, if you imagine, a layered network that we designed for them that was backhaul, which was both microwaved and cabled. We then had 6 cell sites that had 4-channel Tetra. On top of that, we had eNode B laced in. So they had a LTE taking up all the data off the network, although Tetra does data quite well. And then we provided 2 E911 call centers for them and an entire package of hurricane relief and exploratory equipment. So the military, police and others had a complete out-of-the-bag mast kits for 3 different masts, as well as spare handsets and air power and everything you needed. So in case a hurricane decimated the island or another island, they could go and deploy it and create a network. And the biggest thing we gave them is the training on how to use it, manage it, and get the most out of it.
Wow, that's some undertaking that you went there. I mean, to me, like building a hurricane-proof network just sounds like such a challenge. I grew up on Long Island, so we had our fair share of hurricanes. Of course, they're not quite as powerful normally as the storms that would hit Bermuda or in the Caribbean. However, we'd get the nor'easters that would come in and that would that would give networks tons of problems and tons of challenges. And then we would get hurricanes like Sandy would come in and flood the whole area. So when you're designing a network like that, I'm just curious as to what things do you need to take in consideration? Because you've got high wind, you've got massive rain, you've got weatherproofing on connectors and cables, you've got flooding potential. So what are the big things you're taking into consideration when you're designing and building a network like that?
Yeah, and it really is in the planning. In 2016, we sat through Hurricane Nicole, Cat 5, and it hit direct hit on Bermuda. And sitting in the eye of that storm, still using my Sapura radio that worked fine across the island, you realized the steps we'd gone to make that happen. So first of all, yes, that flooding, the tide comes up. So where is everything located? Number one, you've got the rain that comes in sideways. So you putting a shelter over something is irrelevant when the winds start kicking up. So water ingress in an island like Bermuda, where you've got high humidity, I'm sure the Floridians will attest to this on a daily basis. Water ingress is number one for us. IP rating of all equipment or NEMA boxes all round. And then it's resilience. It says 100-mile-an-hour wind rating. That's great. What are you going to do when the wind is 150 miles an hour? And the answer is have a different system. Have a cable if you can, or have a secondary backup. And people who know how to deploy it and use it is the key. So you're constantly, and in the military, we would do this at a brigade level. You would sit and say, okay, what if this happens? Well, we're going to phone this person. Well, how are you going to phone them? On what phone number? Who holds that phone number? Who's going to make that phone call? To that very minutiae point. And we would plan this out. If I'm going to build this network, what happens when this happens or that happens? What happens about tsunamis? What about a drought? What about an all-out power outage for the island? And so what are my ifs? So we deliberately had generators that would auto start or could be started remotely, as well as solar in some places, as well as the power that they would normally have, which all had UPS. And you're thinking layer on layer on layer as an onion, and that resilience is built in through every bit. But to be honest, the biggest thing we can do, and that as RF engineers we forget, is to keep it simple. Sometimes a bit of copper braid and a small radio is enough comms. And if it's really simple, it's harder to break. So when you get these very high-tech systems, sometimes having a low-tech backup is really, really helpful.
I do like how you brought food into your answer. I guess that comes from your background of being a chef. So,
yes, although I wasn't a very good chef.
So that's why you went into RF, is because you weren't a good chef? Is that the real reason?
That's a real reason. 70 hours a week in a restaurant cooking, and I just wasn't quite happy with the quality. And I thought, well, I can either learn or change career.
Oh my gosh, that's awesome. Well, that definitely sounds like an amazing project you worked on in Bermuda, and it certainly puts you kind of in a unique category when it comes to kind of addressing and dealing with networks. Since you built these P25 networks, I don't think we've had a guest who's come on who's kind of gone into the weeds, so to speak, as you have. We've dove into a lot of different topics and conversations. That's really a unique one and a different one. So I appreciate your background on that. So what brought you over to MorCom?
So those of you may have heard of Starry Internet is an ISP based on 5G frequencies. So in 2018, designed and built their network in DC. And basically built one of the first 5G networks in the country for Starry. And it was a startup, and I was working too many hours, just doing too much. And then COVID hit. And so I moved across to the satellite industry. I'd been doing satellite comms in the Army. And so I went back to the satellite industry, and COVID hit, and it was just a horrendous place to work. The satellite industry took a real kicking, and then the C-band got taken off everyone and handed out to the cell phone providers. And so I decided to take 18 months off and raise my kids through COVID, do the self-schooling bit, 3 small children. When I came back to work, I wanted not just a job. I wanted something to challenge me, and I wanted variety. And so when I've been hyper-focused on satellites or hyper-focused on G or hyper-focused on a particular one network in Bermuda, and I decided that I wanted range and I wanted a breadth of projects and expertise. And MorCom is not a DAS company, although we're most well known for our DAS. We are an RF company, and whatever that means. So last week I was in DC. The week before that, I was in Brazil talking about a maritime application for a product we make for the Coast Guard and different navies around the world. The week before that, I was at IWCE talking about public safety and having conversations about the monitoring aspects of public safety networks and BDA monitoring. But I'm also doing a project for Department of Energy where I'm doing projects for pager systems and notification systems, or we did an FCC frequency interference project recently near an international airport. So this mix of stuff that MorCom gets involved in, I wanted to be part of that. And so they needed somebody who had a range, I think, of experience. And so we just found each other at the right time. I think it was really good.
So the stars aligned.
Really did. And I'm not sure it's a romance, but it's certainly enjoyable.
So I think we were talking about a few things before the podcast came on, and one of them was sort of this, I don't want to call it a trend, but sort of here and there we're kind of hearing about repeaters being put on vehicles and different jurisdictions using the repeaters sort of in place of or congruence with BDA deployment. And I just kind of wanted to get your take on that because I thought our conversation was really, really interesting. And I kind of wanted to dive into that a little bit and see what your thoughts or your experiences with that, because I think you've got a little bit of a cool, unique background when it comes to that and how maybe where it did work and where it didn't, or the problems.
Yeah, I mean, it's on the surface, it sounds like a good idea. And the two big examples going round at the moment is down in Ohio, where they're looking at putting repeaters in vehicles. It does make sense because you have a battery in a vehicle that's bigger than any handset, so you can push out more power. And by using that as a gateway, there's a lot of cheap technology around, actually, from the handset vendors to put in a gateway. You have the extra power. You have a roof platform, which acts as a brilliant ground plane, so you can have a better antenna. You get real distance and penetration and things from a vehicle-mounted piece of equipment, a lot more than you would with a handheld device of any quality or scale. We're also seeing in Fairfax and a few others a new product being sold now where BDAs are mobile and they have a kind of a go system that's given to the fire service. They'll take them into buildings when they don't have coverage or set them up in an incident area. And while these things sound like a great idea on the surface, when you really look at them, there's a lot of caveats that aren't really being considered. So this generally comes from the Tetra world. And so this is used quite commonly in the UK, France, and other areas, a little bit in Iraq by special forces. But that's because these are greenfield sites often where they're used. So there aren't interference issues, but it's being managed centrally. Now, when you put a Tetra fire truck next to a building, it's 400 meg most of the time. Yes, you can get Tetra in 800, but generally this sort of technology was designed for that 400 meg band, which penetrates buildings a lot better. Also in the UK, France, and other parts of Europe, their networks are well defined. They know where they have coverage and where they don't. They don't generally have problems in buildings because of the frequencies in use, the power of the systems, and so they can just drive a fire truck and put it where they need it. But the person who's managing that network can see the values of their network. They can see what talk groups are in use, which other assets have turned up, and it can all be done over the air. Everything can be reprogrammed over the air. So interference issues can be seen instantly, managed beforehand, and mitigated. When you have got untrained radio staff, the firefighters should not become radio experts. That's not their job. You're giving them high-tech radio equipment and saying, make that work. You're going to end up with interference issues. You're going to end up with oscillation. Do they really know, for example, in Ohio, every BDA exactly where it is? Because if they go into a building and they turn on their amplifier on their building and it already has a donor antenna on top, you're just going to get a singing loop or oscillation, as you call it here. And for those watching who don't know, the singing loop term comes from HF and VHF communications, and certainly military applications. And it just means I hear you and I repeat everything you say. And then you hear me saying that, so you repeat it and we sing at each other all day. And that's what the antennas do in these situations. They hear each other and they just repeat everything they're hearing over and over again. And it can destroy networks, entire networks. So this is really dangerous stuff to be dealing with, especially when you know it's being used at the time of an emergency. It's the one time where you need this stuff to work. So yes, in the right hands, done in the right way, it's a good idea, but it has to be thought out, really planned well, and the technology has to fit exactly what the scenario and the needs are. And I don't think that's the case in any of these jurisdictions so far.
So, Luke, I want to ask you, you mentioned Tetra. Now, is that an OEM or is that like a network
So
standard
it's a
or
network
protocol?
technology. So
Okay.
P25, Project 25 was generally built by Motorola, and it's a standard they created for the US market. However, Motorola in 1995 were part of a consortium that also built the Tetra standard. So rather than having 2 channels in standard, you have 4 12.5K channel size. So there's more data and you can combine them together and have 28K data going through that on the 400 meg spectrum. Motorola then campaigned to have Tetra made illegal in America while they were spreading APCO 25. So the 2 systems, one spread in Europe and one spread in America. And because Motorola sat in the middle and said, let's keep them separate. Motorola was the biggest seller of Tetra in the UK. They sold the government network for the entirety of the UK. They also now are the biggest APCO 25 suppliers. So they had the best of both markets. In 2013, Tetra became legal in the US, and you can now buy flavors of it in 400 meg, 800, 700 meg. And you can actually buy radios and some equipment now that will switch between Tetra standard and the APCO standard. But you can't do both at the same time. If you buy a Tetra handset, you can only use it on a Tetra network. But the whole point of these systems, these codes, is so they are vendor agnostic. And so MorCom is a vendor agnostic company. We love to make sure that we don't favoritize any company. And so we love standards like these. So APCO cannot just be a Motorola standard. Tate and ICOM and anyone else can come and sell products into that market as the same as Tetra. You can buy Tetra products and they all should work on those networks. But again, it's about the frequencies and how they're modulated.
So could you do, because we're talking about like BDAs and vehicles and things. I mean, I'm trying to think how to word this, but would a Tetra system, I guess like in the UK, be better than kind of what we have here? Because you're talking about being able to manage it and they could see kind of in real time what the frequencies are, what the load is. Can we still do that here in the States?
This is one of those conversations that has been going on ad infinitum. And it's very difficult to say one is better than the other because they are very different environments. So I personally think Tetra is a better technology. However, could it ever have been brought into America? Well, only at the very beginning. I don't think you can successfully bring it to America now. Tetra will travel farther. It costs half the price to have twice as many channels, to have more data. It is more resilient because of the frequencies mainly, but the power outputs is also. So penetration is generally better. There are more manufacturers making Tetra equipment, so that competition in the market drives pricing down and it innovates in the technology within the standard. Having said that, the size of the US, the way the US is carved up into lots of different AHJs and territories, and it would be impossible to go and take away the old VHF stuff and just say we're putting Tetra in. When those frequencies were already in use for aviation, that's the top end of some of the military ground-to-air stuff. And so it would have been very difficult to bring it in. But it had to have been brought in at the beginning. Now you've got APCO 25 everywhere. There's no point changing to Tetra. You would be better off changing to, dare I say it, FirstNet. My opinions on that is also slightly unusual, I think, because while FirstNet is brilliant, they're going a digital route in the same way the UK are and everyone else. They've given it to a private organization, which takes away the competition in the market, which creates innovation and allows the technology to develop faster. It also allows it to grow and be built faster, and it drives the price down. So unfortunately, there's a lot of public safety organizations who can't afford a FirstNet system. They can't afford to pay AT&T for high data throughput and everything else because there's no infrastructure and who's going to pay for it. So yeah, it's a bigger puzzle. It's a bigger piece, and people who get paid a lot more than I do need to understand these things.
Well, you bring up infrastructure and paying for it. This is always a kind of a constant debate in this whole industry, right? So we talk about life-saving, mission-critical networks that get deployed, and the responsibility has now been put on the building owner and the facility owner to kind of figure out how they're going to do that. So whether we're talking about cellular or you're talking about, emergency responder communication networks, the onus then is on the facility owner or the building owner or the school to kind of come up with the cash to put these systems in. However, if you're talking about emergency responder systems, then it's public. It's a government agency that's actually using it, right? So you're talking about law enforcement,
yeah,
EMT, and you're also talking about fire. However, the building owner has to pay for it because that's what the code says. And then the government really hasn't come in and said, well, you know what, maybe we should kind of subsidize this because our agencies are using it. So that's where kind of the problem comes in. And then you've got your cellular component of this. Well, this is the cellular side of it. Should that be considered a requisite for life-saving technology that should be in these facilities as well? Because how can you have an emergency and you can't communicate out from teachers, students, other residents who are inside the buildings in the facility, and not that be considered, well, this is really important too, right? So you're looking at both of this, and then we take all this, and it can be an extremely high cost, and saying, well, building owners, you got to pay for it. So sometimes that's looked at, that's not really that fair, but that's what we've kind of done in this, at least in the United States anyway.
Yeah. No, I mean, I'm a bit of a lefty, and I think that, people's public safety, that's what our taxpayers should pay for. So I think that public safety is an agreement that we have as a society with our governments, wherever we are in the world. I also believe in capitalism, and I don't think you can go and force a company like AT&T or Verizon to put in a cellular network somewhere, because that's at their cost. And so there has to be somewhere in the middle. And the FCC or NFPA have decided that the middleman is going to be the building owner. And that's where the shortfall is going to kind of stick. And they haven't told him he has to have a cell network yet, although he knows everyone who enters his building has a cell phone in their hand. So in a lot of cases, they're putting in cell networks because it's profitable for them to do that, because they can't rent their office space without it, or because they're using systems that use it. Hospitals have a lot of IoT devices that are hanging on these systems. But then if we're going to say cellular, why not say Wi-Fi? Let's say a data system. Let's say that anyone should be able to make an 911 phone call within a building. Oh, and if that's the case, then do you need a public safety system that's completely separate? Now, actually, on the 16th to 18th of June is the NFPA conference this year in Vegas at the Wynn, and I will be talking about ERCs. If it's called ERCs, it's not actually called that in 1221. It's not actually called ERCs as part of the code, or however many R's you put in it. It's actually called two-way communication systems in the code. Well, what does that actually mean then? I've titled my talk The Most Hated Code in NFPA, which is slightly controversial and gets a conversation going. It also makes people go, what's he talking about then? Which is the most hated code? Because everyone hates paying for sprinkler systems that's going to destroy all their communications equipment and their networks and get everyone wet. They're annoyed of how many signs they have to put up for fire exits and all these other things. But actually, my story that I'm going to tell for an hour, and I won't give too much away, is a hero's tale. And the heroes to start with are the RF engineers. We are the only people, really. The industry engineers are the people who understand the code and the technology that's been designed to fix the code and where the gaps are. So we're kind of running with this. We're the ones having conversations like this on YouTube and in other places. DAS University will put a lot of effort into teaching people what the code is because you're experts in it. And you'll teach people what the equipment is because you're experts in it. And you'll teach them the physics of how that equipment works because that underpins everything. The building owner doesn't know any of that. The firefighter who's entering the building doesn't know any of that. And the AHJ, who's responsible for all kinds of codes, he doesn't understand it either. So you kind of ask yourself, well, who else does fill that gap? But my response is we should not be the hero of this tale. NFPA isn't really the bad guy, the villain of this story, with the owners being the victims having to pay all this money. Actually, that the heroes will always be the first responders. And so we should all have a view of let's help them complete their tasks in the best, easiest way possible. And let's help the AHJs help them to do it. And so I think number one is education, I think is the key thing. The problem is we have to have a set book to educate people from. And at the very highest level at the moment, that is the NFPA standards, 1221, 1225, 72, and the rest. But also they have to really want to do it because we're tens and hundreds of thousands of dollars here for the building owners. So they have to want to have this in and working, and they have to understand what happens if they don't. And at the moment, NFPA is a guideline more than anything else. It's if you don't have a working system when the firemen come in to fight the fire in your building, there's very little they can do. They can take you to civil court. And as far as I can find out, no one has ever been taken to civil court for not following NFPA directives, including the Wells Fargo building in 2023 that went up in North Carolina. The firemen were literally having to break windows and relay messages out the windows as the building is on fire and people are stuck in elevators. And that could have been a real loss of life. It was not only a massive building, a huge investment for Wells Fargo and the people of North Carolina, it was also a really dangerous situation that could have got very much out of hand. And yet, the FCC didn't step in at all. All that happened was the fire marshals spent 9 visits over the next year making sure that building came up to scratch, right? Which is great. Let's help people get better. But when there is no stick, there is no carrot, then what's the point? Why would they spend $500,000 for a building of that size to put in an ERCE system? It's a really hard sell.
So do you know the age of that building? Do you know when that building went up by any chance? I'm just curious.
It was August 2023, I think. I've got this written down, but don't quote me on the date. And it was only a few years old, the building. It wasn't, and it was the biggest building. It was the most prestigious building in the city at the time. And there's quite a nice news report. Actually, local news did quite a nice news report on it. So there are videos on YouTube. The issue is, in the same jurisdiction within North Carolina, within 2 years, I think it was 2 years earlier, a guy got on his little radio and he tuned into the police scanner and transmitted over 911 calls and was fined $40,000 for doing so. I've got the details of these on my NFPA talk, but you just see that he may have interfered with one call and he gets a $40,000 fine as an individual. A company as wealthy and as big as Wells Fargo spending $1 billion to build a skyscraper, they get in no trouble at all for not having the right, fire protection equipment in their building. So we can talk about what the code says and what it doesn't says, what the HJs dictate or not. If there's no stick and there's no carrot, then we have to find a better way of getting this message out there.
That's like a mic drop moment right there. And that really is. That's a mic drop moment where you've got building owners, and it's not like they don't have the money. They have the money. So yeah. You're telling me, and I know a little bit about this incident, and I didn't read into it a ton. I do know that they were having the coverage problems, the connectivity problems with their radios during it, which it became a problem. So I read, it was a very top level story when I looked into it, but I find it very intriguing. It seems like you know a little bit more about this, which is unique in a sense where how did we get to that point? The building you said was built just recently, and there was no code requiring them. Do you know if it was a high rise?
Yeah.
It was considered a high rise too?
Oh, it's more than 15 floors.
Oh my gosh, yeah, that's a high rise.
Yeah, I think it's Charlotte, North Carolina. I will have to go and grab my
maybe Silver City. Maybe that's near
Siler City.
Siler City, Siler City. So Siler City.
So there's a CNBC story on it in December.
They
had a whole thing. But what you really need to do is all come to Vegas in June 16th to 18th and watch my talk. There's a handout as well that gives you these, it helps you with the code to understand what code provisions there are. So you don't have to read the entirety of the NFPA library to understand what's going on. We'll also give you incentive as to why. But more importantly, for the building owners and for AHJs, actually, gives you a general understanding of what this system is. At its core, very basic level. You don't have to be an engineer to understand. It's taking a signal, it's amplifying it, pumping it around the building. However, it has to be done in a certain way so it doesn't interfere with everything that's going on outside. The person that is responsible is the FCC license holder, and whoever's put their name to that at the FCC, an AHJ, a fire chief somewhere, they are ultimately responsible, and they are the ones who can go to jail if that system interferes with an emergency service operation. So at the moment, the onus is really on the FCC license holder, and the building owners have to pay, but they're not the ones who get in trouble.
Yeah. It's kind of an interesting puzzle right now. But I agree with you in a sense where it really does come down to education and understanding, because from a building owner or a facilities owner, I'm going to want my facility to just be safe. And that's what is really important, and safe for the residents. I mean, certainly, how can you have grandma falling down in a subterranean parking lot, right, where she can't call out of the parking lot because her cell phone doesn't work, and first responders can't communicate once they get in and basically tell them, well, grandma's actually okay, stop your resources, or whatever the issue may be. I mean, we can't get to that point. They've got to buy into this. So we need to be able to educate them and help them understand why they should do it.
And they can be selfish. They really can. If you're renting an apartment in a big multi-dweller unit, or if you're renting office space and you own this building, do your renters want an office that doesn't have cellular or the correct fire safety equipment? Can you sell more office space than the people next door, advertising the fact that you are fireman friendly? Do you know that you have got their backs in case of emergency? Because you tell them where the fire exits are when they first do their first initial walk around. You can tell them where the BDA antennas are as well, and they'll know they're safe when a fireman and a police officer, EMTs come into their building. It's a sales point for them. Let them be greedy. It's fine.
Go ahead, Gil.
Well, no, I was going to say, Luke, too, like when I was an integrator, I talked to a lot of different building owners, all sorts of different verticals. It could have been healthcare, hospitality, what have you. And it was interesting because I guess to your point, it was always kind of a selfish reason to do it. Like, I did a lot with hospitality, so it could have been, hotels or what have you. Well, we just were required to have this public safety system. Well, great. Have you considered about cellular? And, for us, well, I think a lot of us who've been in this industry a long time, it's really cellular and public safety. You need both. So you can cover first responders with their radios as well as their handheld devices, and the patrons, so they have their handheld devices. They can call out, they can call in, all that type of stuff. But it was interesting because they would say, like in hospitality, no, we don't need that system. But invariably, they would always call me back because there were some bad Yelp reviews, something to the effect that, this place, don't stay here because my phone doesn't work, or their Wi-Fi is awful, your phone doesn't work. So I could see your point, but there's almost a bigger picture to it where it is, a dollars and cents thing. Well, I have to, as a building owner, I have to spend the money on this public safety system. It's mandated. And so do I want to do this on cellular too? And I agree with you guys. It's to the point of, just the education, or just to see that there's a bigger picture to it of maybe for some selfish reasons. So you get better reviews on, online, but also from a life safety perspective. Yeah, Peter, what if one of the patrons, someone's grandmother, whatever, fell, or who knows what? It could be a lot of different things, but they have the ability to communicate in and out, regardless of the situation, regardless of the event.
And we do have an in here because of that. So people are prepared to pay for that cellular network. They are going to use it. When you buy a cellular DAS, you're using it yourself. Your customers are using it. You're jacking their prices up a little bit to pay for it over the next 10 years. Great. But actually, now you have that DAS in place, putting a BDA on the wall for the public safety frequencies in your area, having compliant passives across your network, it's actually not very much more as a CapEx to put in the public safety DAS at the same time. And having that peace of mind, I personally think that we should be lobbying the insurance companies. And I think these big buildings should be insured based on the protection that their building has, based on their NFPA rating. And it's not just ERSI's systems, of course, it's all the other stuff. And I have spoken to some insurance agents who do insurance inspections on new builds. So they look at new builds to comply, to confirm and give them insurance. And we've lobbied them to ask them to say, well, does it have an ERSI's kit? Are people safe? Are they meant to have one according to the AHJ and NFPA? And do they have it? Does it work? Can they show me a certificate to say it's been checked and working? And if it does, should they get a few % off of their insurance rate or be able to gain the insurance they want? These conversations have to be had at, a bigger level. Insurance companies just want to make money. But I think it is. If you sell on the cellular, actually the public safety is a pittance. If you Google it, cellular is around $10 per square foot. Public safety is between $2 and $5 per square foot. Now at MorCom, we try to keep everything under $1.50 per square foot for public safety. It's actually even cheaper than that. But there is a price difference between that cellular and the, I want to keep saying mobile. That's why I keep stuttering. Apologies. It's a British thing.
So how does MorCom keep it a $1.50?
Number one, we are vendor agnostic. We're really proud of that. And so we look for the right equipment at the right price for every project we do. We're very good friends with lots of people in the industry. There's lots of good BDA manufacturers. There's lots of good splitters and cable manufacturers. And if I was to go to Fiplex or Combo or Wilson, they would give me a bomb, or my IB Wave spits out a bomb and says, go buy all this stuff. And we don't go to the same vendor for everything. I buy my cable where I can get the best price on my cable. And I buy my splitters the best place I can buy my splitters, as long as they give me the right RF performance, which is key.
Luke, so you mentioned something about your systems at about $1.50 a foot for an ERSI's or an ERCS. I'd love for you to elaborate a little bit on that about how MorCom can accomplish that. I think a lot of people would love to know.
Yeah, I mean, it's first of all, it's being vendor agnostic, and it's something we're quite proud of. We have really good relationships with a lot of BDA manufacturers as well as sign exclusivity. So when we go to a project, it is a different build, it's a different BOM every time, and we go and price every individual item separately. So depending on the size of the building, there are some vendors we'll go to and say, okay, these systems we know can handle a building of this size. Or if there's specific requirements, if it's Class A, Class B, we'll go to different vendors based on technology, and we provide the best technological service we can, and we shop around on behalf of our customers, and we pass those savings on. So we make enough money to feed our families, but actually we're not trying to rip people off, because our intention is to get a safer environment for everyone. And we hope they come back to us for their cellular DAS and for their Wi-Fi network and for all their other RF needs. And by having those good relationships and that, really good price point, the more necessary stuff like the NFPA required ERC's systems, we deliberately try and get it as cheap as we can for them, and while solving the technical barriers.
Do you guys have a footprint of where you work at, or is there, you're out of the DC area, right? So is that where you kind of do most of your work, or?
Yeah, and this is one of those questions that's very difficult to answer. So we're in Ashburn, Virginia, just next to DC. That is our stomping ground. This is where we are best known. We do a lot of work in DC, Virginia, and Maryland. Having said that, we are a nationwide company and we've provided systems around the place, although we don't generally go looking. Often it'll be federal customers around the country that ask us in, or customers that have moved or have other offices out of our normal jurisdiction. We don't go hunting on other people's patches, but we find ourselves there. Having said that, we do a lot more than BDAs. So for other RF stuff, we're very heavy in South America. We're heavy nationally. We do a lot of airport weather sensing and data management systems. And our founder, the company was founded over 40 years ago by Manuel Ojeda, and he's one of the leading experts in weather systems and bringing weather data back to a central repository and reporting to aircraft. So we do a lot of that. But again, RF is RF. Physics is physics. So it's all in the same wheelhouse, really.
So I think there's also a lot of concerns or questions around the industry about, I don't want to say a rogue BDA, but maybe a malfunctioning BDA and monitoring those things and how you do that, because well, it's pretty simple if you got a small town and you got a handful of BDAs, and you're maybe near a larger town and you've got a couple of high rises and most buildings don't need it. But like towns like Greensboro and other places that just are growing and growing, and how do they manage or monitor those things, I think becomes a real challenge and a real problem. Do you guys touch or have any kind of solutions for anything of that nature?
Yeah, so if you think about Washington, D.C., here's a little quiz question for anyone listening. What is the most important communication system in Washington, D.C., and which agency is pushing the push-to-talk on that system? And when you think about that question, you realize how many agencies there are, how many systems there are. So the chances of having a communications issue, an interference issue, is massive. Now, that goes for any metropolitan area, bigger area, and ERC's has its own individual problems in built-up areas because everyone's told you have to have a system. There's a load of companies that set up to put in these systems. They're not talking to each other, so now there's a BDA, there's a donor antenna on every roof. And then you end up with massive issues. And that is the frequency license holder's problem. That is the AHJ's job to sort out. So in DC, for example, OUC, the Office of Unified Communications, who are the AHJ here, they actually put out an RFP and said, how do we monitor this? How do we have the power? Is there a product that we have that we can just push the button on a BDA remotely to stop its transmitter, just in case we have a massive problem and someone more important than us is being interfered with? The answer was no. And so we built one. And monitoring of BDA systems is in the code. It is fuzzy at best. It is vague at best. Theoretically, you have to have someone sat in reception or in your basement watching the lights on an annunciator panel or at your fire alarm wall. And that really doesn't happen ever. It does say in 1221 that it should be working at all times. And how do you know it's working at all times unless you're monitoring it? So it infers that you should be monitoring your system at all times. But the AHJ's responsibility, the license holder's responsibility, the FCC states they have to manage and they have responsibility for these systems. So we created a product called Connexus DAS, which is a highly secure device that you put next to your BDA. It encrypts all the data that comes out of the BDA, sends it onto our secure cloud, which is FedRAMP Secure Cloud. You then get a crypto key in your software. You download the software. That allows you to see your map. That shows you in a traffic light symbol every location on your map where you have a BDA. If it goes red, you've got a problem in that location. Amber, there's a problem that's not breaking the code because it's set to the code. And if you click on that traffic light, your annunciator panel comes up. And that annunciator panel has two buttons on it. One mutes the antenna. So you stop traffic coming out of that donor antenna, which is really important to have if you're the FCC license holder and you know what you're doing to be able to stop interference issues. But it doesn't turn off the BDA. So you can press the other button and it takes you directly to the GUI of that BDA. And if you have the login credentials, you can then go in and see what's going on with that BDA. And you're able to do that. We literally have just installed our 200th site for OUC in DC alone. And so they literally have 200 little icons on their screen now. And it's something that we think that South Carolina is doing reasonably well. They're doing it the hard way because they are every license agreement that gets signed by them to say, yes, you can have a BDA. They put it on a map that is shareable online. It's actually a very good website they have. And it tells you the make and model of the equipment that's been put in there, which company put it in. And so there's some accountability there, which I think is brilliant. Unfortunately, they don't have the ability as an AHJ to log in. They do know who to speak to log in, and they curate that database reasonably well. So this is kind of the next step from there. But I just don't think anyone else in the country is doing it right now. And I think if you're a license holder, if you actually are accountable to the FCC, who have got a lot more force than NFPA, it's something you have to think about on what your responsibilities are. And monitoring is a big one.
Fantastic. I love it because I think if we're going to go through the efforts and spend all the money to install these systems and we know the consequences of when they're not working right, how they can affect the macro and cause a lot of problems, not only affect the macro, but you can also affect cellular signal. You got to find out where the source of that interference is coming from and how to resolve it. And if you've got to go, even if you know where it is, well, then you've got to go reach out to the building owner. Well, how many building owners are sitting by their PC ready to get on the call to go call the RF guy who's going to go ahead and shut that down? That's a really tall thing to ask of these guys who aren't in that situation.
How many building owners are there that actually sit in the building at all? A lot of our buildings are federal. 100 of these 200 are federal buildings. The building owner might be renting office space. He's not sat there. There could be 15 different companies in that building. They don't care about the ERC system.
Not at all.
So who is taking responsibility for monitoring? And where does that responsibility lie? As a building owner, as a renter of space, I think you have some responsibility. And I think you should look after your people that work for you or that rent from you. I think that's a moral duty that you have. Legally, when the court cases come, because that's what most people care about, when there's a fire in their building, they phone the lawyer first, then they phone the ambulance, and unfortunately, that lawyer's going to say, you were responsible to put in a system and make sure that lives were savable. And if you didn't, or you did, but it didn't work, you're liable. So being able to monitor it. But we've actually had good conversations with integrators who are saying, well, look, these buildings need to be certified every year. They want a support contract when we put in the BDA. But that's a lot of driving out of our office. If you've got a large jurisdiction, if you're a national company, or certainly you've got a big region of the country that you deal with, if you're in Texas providing BDAs, what's the drive between your two furthest customers? That vehicle role on that support contract is your time as your profit margin. Throw a device in there, pay a small monthly fee, and you can monitor it from your office. And it's actually as a business proposition for an integrator, the AHJ is happy. They can get a login as well if they want it. But they also want someone who understands the technology to go in and fix problems. So the AHJ, I wouldn't necessarily want playing with the settings of my BDA, but being able to mute possibly and make that decision. But actually, for the industry. This is a product that maybe the industry would like to look at, so at least we get the monitoring word out there and things are being monitored by someone who understands what they're looking at.
That's fantastic. Awesome. Well, Luke, we're going to come to a close here real soon. Before we end this episode, is there any other thing that you want to touch on to kind of close out this wonderful discussion that we've had about remote repeaters and BDAs and monitoring and Tetra, which was something new that I learned about, which was really I was like, Tetra, what is that? Is there anything else you wanted to hit on before we wrap this one up?
I mean, there's a lot I could talk about. I'm one of these people that could talk all day. I'll leave it for another day. Maybe you catch me at APCO or NFPA if you're around. I think they're my final two for this industry. Or give me a call. And if anything Ursies, I'm always up for a conversation. But my bigger message to everyone is have the conversation over a cup of coffee in your office, with your customers, with your AHJs, with the local emergency services. Have these conversations, continuously. And I want to thank you guys, Gamma and DAS University, for having me on and for spreading this message. I think it's brilliant work that you're doing. Everyone should definitely go and get trained to some level. I think it's vital. Education is going to save people's lives. It's that simple.
Awesome. Same here. Thank you, gentlemen. Appreciate the conversation. It's been fantastic. Have a good one.
Yeah,
Thanks
you,
very
Luke.
much.
Appreciate it.
Bye-bye.
Thanks, guys. Bye-bye.
DAS Talk by Gamma, keeping you connected and protected.